now that we've seen that, so this A right here indicates that the coefficient of x, sometimes it's not a phantom one. So you may see a coefficient of your x squared, which is what the A is representing. Right? A, B, and C, these would be numbers somewhere in the expression for us. So what we're going to do is we got to take the A and C value, we're going to multiply those two values, and we're going to find the factor pair from the A times C, whose sum is still the center coefficient, the coefficient of x. Once we get that, then we will factor by, we're going to split the middle term up into those two specific factors, and then that will allow us to factor by grouping, which when we do, it should work out very nice. Just be careful, because sometimes, especially with these coefficient of x squareds that are not phantom ones, sometimes you may factor out a 2, but you should have probably factored out a 4. Okay, so just always double check in the end to make sure that none of the there's no other factors to factor out. This middle one, right? Again, this goes back to us. We're going to change this center term into two separate terms, but they're going to always add up to this one, and that comes from this finding the factor pair that adds up to B. All right, so for this one, and I probably should have mentioned this before, we do have we don't really have the form right here that we just saw, right? It was saying ax squared plus bx plus c. The problem here is that it's an x cubed leading term, right? Then we got an x cubed. So right here, we got 56x squared and then plus 180x. Yeah, from that we can factor out an x from all three of those terms, not even just the x, right? The other thing I notice is that the coefficient of x cubed and the x squared and just the x, these are all even. So I should at least be able to factor out a 2. Possibly more, okay? So that's what I'm gonna do. Yeah, I think so, right? So I'm gonna start with the x because it's the first thing that I notice, which usually with the variables, once you get enough experience with this, the variable becomes the easier of the two. So I'm going to factor out an x. Okay, now from each of those terms, the x cubed now becomes, from the first term, is an x squared. From the second term, the x squared becomes just an x. And then the last term here, we took this x out. Okay, so we factored out, we pulled out an x from each of these three terms. This is what we're left with, but like I said, we should be able to factor out not just a 2, but yeah, we should be able to factor out a 4 from all 4 of these, right? So I'm going to also factor out a 4. From the first term, if I factor out this 4, if you want to show that 1, that's fine. I mean, just to kind of relate it to what we've seen already, I'm going to make it a phantom 1 though. And then we got 56 divided by 4, which would be positive 14. And then 180 divided by 4 would be 45. Thank you. Yeah, and that looks good. Now, the good news here is that we factored that out, and
You can factor more.
yes, yeah, we can factor more at this point. Yeah, so, but now, just the way that we have this, the coefficient of x squared is a 1. So, I'm gonna skip the factoring by grouping. I'm gonna set up my two binomials with the x's, like this. And all I gotta do is find two factors of 45 that add up to 14. Now, I'm gonna go through these one by one. But once I find the one that is 14, then I'm good, right? Now, yeah, so some of you guys know what it is. I'm gonna go through some of them here. So there's all right, so then we got, it would have been 1 times 45. Now, 1 plus 45, of course, isn't gonna work. I can't divide by 2, I could use 3. 3 times 15, 3 plus 15, those 18, which is pretty close to 14, but it's not exactly 14, right? Can't divide by 4, but 5 would work. 5 and 9, boom, we found it. Okay, now I went through the positives, which I usually will do. If this number were negative, then I would have to have one be positive, one be negative. This one's positive, so I just went through the positives. If I didn't find any positives that worked, then I would have to go into the negatives. But I found one that does work, so I can fill in those values. I got a positive 5 and I got a positive 9er. Now don't forget the 4x that was out there in the front, right? So it's this full expression right here. Now, yeah, so from this original, you could have factored by grouping, even with the x squared stuff. Now, just like we would, and kind of showed in that last slide, we pretty much ignore the x squared. But what we need, kind of here to start with, is the leading coefficient 4, and then multiply it by what would be in this case, it's a coefficient, but it should be a constant usually. And if I was prepared, I'd have my calculator out. But 4 times 180, enter, 720. So the multiplication of these is 720. Now what we need is a factor pair of 720 that adds up to 56. Now instead of doing this factor pair by factor pair, let's skip a little bit of this. So the first one that I was thinking of was 72 and 10, and that's pretty nice. But if I add those together, it's 82, right? But it's close, it's fairly close to 76.
76?
Sorry, 56. I was close. We'll say that I was close. Thank you. All right. So we're going to take 720. Let's divide it by, let's try 20. That's 20 and 36. Now, I literally was just fishing right there, but I found it. 20 plus 36 is 56, right? So, again, if you didn't notice, the greatest common factors, which we just did, you could have said, I found 56, which means that the middle term you could have split up between 20x squared and also 36x squared, right? That's positive. These are positive, by the way.
It seems like this way we take.
And then we do have the rest of it, right? We got 4x cubed, and then we got the positive 180x. Okay, now, again, we took a trinomial, we factored it into 4 terms, or we split it into 4 terms, and now we're going to factor by grouping. So from this first set, I'm just going to focus on one set at a time. I know I can factor out a 4, and I can factor out an x squared. What I'm left with from the first term is just an individual x, and then we got 20 divided by 4, which is 5, and I took out both x squareds right there. You see how it's already forming with the one that we have to the left? All right, so that's that one. Now, of course, the next one, I'm leading us into this, but I'm expecting this to be factored into some kind of x plus 5. Let's see if it works. Okay, so I'm looking at 36x squared and the 180x. I can factor out an x from these. So it looks like we should be able to factor out 36. Some students will say, how do you know it's going to be 36 right here? Because I'm expecting this to be 1x, and right now it's a 36x squared. So I should be able to factor that 36 out. Let's find out, though. I'm going to use my calculator. 180 divided by 36. Enter. Boom. It works. So 36 can be factored from both those numbers. So here's what happens from here, though, is that from these two terms, I can factor out an x plus 5, which we can see in the answer. But what I'm left with is from the first term there is 4x squared, and then the second one is a 36x. So it doesn't quite look like the answer that we got, but we see that this second binomial that I have can be further factored. So setting aside the x plus 5 right there, let's factor out from there a 4. So 4 divided by 4 is 1. 36 divided by 4 would be positive 9. And then also the x. So then we got an x left over from the first term. We took the second one out, and just writing this a little different, now I will apply the x plus 5. And we see, well, once I get rid of that, I'll just make it a phantom 1. Now we see that we end up with the same answer.
Well, you just reverted it.
So the last thing you should always do with these is check, right? Because some students, here's one of the mistakes we see with problems like this. Students stop right here. Hey, look at all this factoring that I did, and it felt good, but you could have factored more. Okay, so just be careful on that. Always check your answer. Make sure, like the x plus 5, of course, there's nothing we can do there. You can factor out 1 many times if you'd like, but it's in this one, right, that you could have factored more out. And yeah, so this one, I have the x plus 5, then x plus 9. This one, x plus 9, then x plus 5. That doesn't matter. It is exactly the same answer, just in a different order, and that's okay. So you can see, through this process, there is the opportunity to make mistakes, which I've done as well. And we should get used to it because we're just practicing, right? So get used to making mistakes and then needing to go back and check. But yeah, you can check this by just simply distributing, for example, the 4x into the first parentheses and then using, I would say distribution, but FOIL, and then making sure that you end up with the same original expression that you start with.